All right, so now that you have completed the constructing triangles activity, let's just go back and let's process our results here. Now, this is all fine and dandy that you can draw these different triangles, but what does it mean? Let's go in there and figure some stuff out. So we know that no triangles are possible with this one. Well, what are the steps that we need to take? So the angle that was given was 30. So sine of 30 equals, we know that sine of 30 degrees, we know that from our unit circle, that's 1/2 or 0.5. So if we were to consider this as our given, now the only time that we really need to worry about it is if we have an acute angle. Okay, so if we have 30 degrees here, this one right here would be opposite of our 30 degrees, and this one right here would be adjacent. I know that this kind of looks like a right angle triangle, but it's not related to our right angle triangle at all. The opposite over the adjacent. So let's look at the opposite here. The opposite of C is going to be little c, which equals 4 centimeters. And this guy is going to be opposite our B. So this is going to be our little b, which equals 10 centimeters. So what we want to do is we want to find out what the ratio, the opposite to the adjacent, is going to be. So opposite over adjacent equals 4 over 10, which equals 0.4. Now here's the thing. Sine of 30 degrees is greater than 0.4. So there are no triangles. So let's write this up as something a little bit more official. If theta given is less than 90 degrees and the side opposite, this divided by the side opposite divided by the side adjacent is less than 1, then no triangles are possible if sine of theta is greater than the opposite over adjacent. Now let's look at this one. There's one triangle that is possible, and we call this one our B. So this is our little b, and this is our little c. Now here's the confusing bit. This is also our opposite of our given angle, which is 30, and this is also our adjacent. So let's see. So we know that sine of 30 degrees is 1/2. Well, what is opposite over adjacent? Well, that is 5 over 10, which is 1/2. So sine of 30 equals opposite over adjacent. So what can we say here? If given angle is less than 30 degrees, less than 90 degrees, and opposite over adjacent is less than 1, then one triangle is possible. Then one triangle is possible if sine of theta equals opposite over adjacent. Now this one right here, there are two triangles that are available we should be able to see. There's one I call my my acute triangle because this one right here is acute, and my obtuse triangle because this is greater than 90. So let's look at this one. So if this is C, this is going to be B, this is going to be little b, and this is going to be little c. This is also going to be little c. That's the thing. Because we know that little c is 6 centimeters. So it can either go this way or it can swing and fit this way. Because we know there are certain things for certain. We know that this is 30 degrees. And we know that c equals 6 centimeters. And we know that b equals 10 centimeters. But it doesn't say anything about the length of c. Sorry, it doesn't say anything about it does say the length of c, but it doesn't say anything about this length right here. This length can be anything. So, we know that sine of 30 degrees equals 1/2. Opposite, okay, the side that's opposite the acute angle, which is 6, divided by the adjacent one, which is 10. So, opposite over adjacent is 6 over 10, which is 0.6. So we know that sine of 30 is 0.5, which is 1/2. It's less than 0.6. So sine of 30 is less than opposite over adjacent. So if theta is less than 90 degrees and opposite over adjacent is less than 1, then there are 2 triangles possible. If sine theta is less than opposite over adjacent. Now with our last one we said that it is too long, okay? But we must extend the base. But if we do extend the base, okay, if we go like this and we draw a triangle that is 12 centimeters, we would have opposite over adjacent, which is opposite would be 12, the side opposite the angle C, and we would have a b that is 10. So that is 1.2. Now that's greater than 1. So we know that if we extended the base, there would be 1 triangle possible. So I'm going to kind of give you some summary notes here, just so that you can have a nice set of notes here. So the first question to ask yourself is opposite over, is theta acute less than 90 degrees? If your answer is no, then 1 triangle possible. What if your answer is yes? You have a few options here. The next question is opposite over adjacent greater than 1? If your answer is yes, then 1 triangle. Hey, come on, buddy. Possible. If the answer is no, then we ask ourselves a series of questions. Is sine theta greater than opposite over adjacent? Then no triangle possible. Is sine theta equal to opposite over adjacent? 1 right angle triangle. And then option number 3 is sine theta less than opposite over adjacent. Then 2 triangles possible. This is going to be key, okay? Key for lesson 6. Because we're going to be dealing just with the ambiguous case, meaning that there are 2 triangles possible.